So I will start explaining technical details. Federico will continue, and then there will be a demo on Lightning operations together with RGB, which will be made also by Federico and his team. So my name is Maxim. I'm from LNPBP Standards Association, and I have this joke that I'm CEO of association, which means not the manager, but engineer. Federico and his team, they are from Bitfinex, and they are doing also applications on top of RGB and building adoption of RGB itself. So I would start with a small historical note that originally RGB was created by Giacomo, based on Peter Todd ideas, that it's the way how we can bring color coins to Lightning, meaning how to make Lightning full of shitcoins. And that was how it all started. Fortunately, it hasn't happened that way specifically. We still don't have a lot of shitcoins on Lightning. And so that's because RGB has mutated through all these years into being a smart contract platform, such that shitcoins which will appear on Lightning will be much more powerful, and you can do a lot more scam with them, like AMM, liquidity pools, all the DeFi stuff. So that was the result of evolution of the RGB protocol. Saying seriously, the RGB, if you think about Bitcoin being money and Lightning being a scalability layer for Bitcoin, RGB is a programmability layer for Bitcoin. And that is really important because the absence of programmability in Bitcoin restricts its own adoption as a tool for the real economy to run on. Because if you would like to build a decentralized trustless systems, you need much more than the money. You need to do something with this money, and to do something with this money in trustless way, meaning smart contracts. And these smart contracts should be as advanced as possible, meaning they could be running the full Turing complete machines such that you can express complex concepts with them. And additionally, to just bring the programmability, RGB runs a client-side validation, which is very important in terms of the scalability. And because of that, RGB is also interoperable with the Lightning Network. Basically, you can do RGB operations on top of the Lightning channels, which also implies that this smart contracting solution is scalable and much more scalable than any blockchain-based solutions for the smart contracts. And finally, the third quality is the privacy. Again, because the data are kept by the clients, the state of the smart contract doesn't present in blockchain. You can't use any chain analysis tools. There is no transaction graph. And we also use zero-knowledge technologies inside to hide the historical data. That all means that RGB is also probably one of the most private smart contract systems out there. And with this layerization, RGB being a clear, distinct layer from blockchain and from Lightning Network, we got literally for free all the compatibility and interoperability with existing innovations in Bitcoin and potential future innovations. So if Bitcoin will have another soft fork and there will be Taproot version 2 or any other kind of stuff, it wouldn't affect RGB, and RGB will be able to leverage all these new things without changes to the protocol and existing data. There is already an ecosystem appearing around the RGB. So there are 2 developer kits, 3 wallets integrating and already working with RGB. There is a set of exchanges that have teams or announce their plans to do something with RGB. First investment happening, media coverage increasing. And the most important is that we have quite a lot of people already on GitHub. And the development, there are already several teams, independent teams, who contribute to the RGB development coming from different companies. The question we always hear since the last year is how you compare RGB to Taro. It's a really hard question because it's hard to compare when somebody took the results of several years of work and fundraised from them 80 million and just restricting some functionality. So that's basically the answer about this comparison. The more real story is that Lightning Labs, of course, they knew about RGB, and we've been working and talking with them, and they were even setting up the team for doing RGB integration into LND. But at a certain moment, they just disappeared, and then a year after they reappeared, fundraising 80 million. So that's the short comparison. Feature-wise, the difference is that Taro is just about assets. It's not about programmability, and it's early alpha. It's not working. Like with RGB, you were able to do the transactions, including transactions on Lightning, more than 2 years ago. Taro is still in the phase of writing the code. So these are quite different projects at the end of the day, because Taro is just assets and not the full smart contract system. Several words how specifically RGB works from the end user point of view, because the workflow is quite different from the workflow you have in Bitcoin and from the workflow you have in Lightning channels operations. So you have a Bob, which is a user. He is Bitcoiner right now. He has his seed, which he needs to back up, and he has a wallet descriptor, which he also needs to back up. If this is a non-trivial wallet, for instance, it could be a multi-sig with some time locks. So before RGB, this is all information that Bob held, which has to be kept private and backed up properly. Now, when RGB came, it introduces several new concepts. The first one is the thing we call stash. And the stash, this thing, in red, in orange, I show everything related to Bitcoin, pure Bitcoin. In red, I will show everything related to RGB and client-side validation. So the stash is the client-side validated data, which are actual history of the RGB operations, starting from the genesis of the creation of RGB smart contract. And this history is committed into blockchain, but the actual data into Bitcoin transactions, but the actual data has to be kept by the client himself. So this a bunch of the data which can be quite large. So we may talk about gigabytes of data, still much smaller than the blockchain, because it's basically a shard. It's a partial view of smart contracts you're participating in. Not all the smart contracts in the whole world, like in Ethereum, you don't keep all of them, you don't verify all of them, you keep just the smart contracts you own some assets or you are a participant of, and also you don't have this whole smart contract, you have a partial view of it on the part of the history which is related to your participation in this contract, to your assets. So this is quite small amount of data comparing to any blockchain platform, but still we are talking about megabytes and gigabytes. So it's much larger than the seed and descriptor. So we have this stash thing. And how you can get any new contract, let's say you was in this state and you would get something from RGB, well, you need to find a thing we call contract consignment. It's a package which represents the public information about the smart contract, its genesis and meta information around this genesis. And how you can discover it? Well, basically you go into internet, so it's outside of the protocol. You can receive it through the email message as a base 64 armored message inside the email. You can find it over the internet as a binary file, or you can download it from the Lightning Network, not the Lightning Network itself, but the layer on top of Lightning Network, which is called Storm, and which is the layer for data propagation and storage inside the Lightning Network. So you can also do that in decentralized fashion. And once you get this contract consignment, it gets into the stash. So it initializes the stash with its own data, and then you can become a user of contract and you can do some operations. For instance, let's say that now you know about some RGB contract, and there is an Alice. She holds an assets under the same contract, and you would like to take this assets from her. She would like to pay you for something. Or like when we talk about this scenario, it doesn't mean that it's always payments and it's always assets. It can be any operation with a smart contract. Like for instance, you can stop something related to the naming system or identity and so on and so forth, or NFT. So the scenario is the same. There is Alice, which has something in RGB, and there is Bob who would like to acquire something and become part of the contract. And the first step for that is that Bob issues an invoice. And an invoice is having a form of URL, which specifies under which contract, under which interface, and so on and so forth. So it's just a string, which is sent to the Alice in any way. Like you can use QR code, you can use email, or you can use again a storm and send it through the Lightning. Once Alice got it, she does two things. First of all, she prepares a thing which is called transfer consignment. It's a package of client-side validated data, which Alice had before, so it's a slice of this stash. It's an extract from the stash, which contains also a new state transition that gives the Bob participation in the smart contract. So these are the client-side validated data. And the second thing she does is she creates a witness transaction, or in case of Lightning, this will be update to the state of the Lightning channel commitment transaction. And she commits in that witness transaction to this new state transition in RGB that gives Bob the state. She sends this transfer consignment to Bob, again through any of these channels, and she keeps this witness transaction for herself, signing it, but not publishing, or not even signing, but just keeping it locally. And on the very next step, the Bob, when he receives the consignment, he does the validation. If he's happy with the validation result, he includes it into his own stash, and he returns back to the Alice signed payslip, which is basically a signature over the ID of the consignment he just received. And why this payslip is needed is because it informs Alice that Bob has accepted the transfer, he is fine with the transfer, and now she can sign and publish her witness transaction into blockchain, such that this operation actually committed to the blockchain, and Bob indeed receives the state. Because if Bob doesn't sign, she doesn't publish the witness transaction, Bob still doesn't have the state that was sent through the consignment. So we have a three-stage process which happens between the users of the RGB. The bad thing that it's more complex than just doing Bitcoin transaction. The good thing, first, you can do it over Lightning Network, so it's not that much problem. Second, you can skip this third round, so Alice can publish this witness transaction without waiting for the payslip. And in this case, you would just have 2 rounds between them. And because you have 2 rounds, you don't require both users to be online. So the way it can work is that Alice receives invoice, like scanning QR code, so it's not interactive. Then she creates the consignment and witness transaction. She uploads it to a certain server that they agreed with the Bob or to the Lightning Network, and Bob at this moment is offline. She publishes witness transaction, and then later, several days even later, when Bob gets online, he downloads the consignments, and now he can do something with the assets he received. So that's the basic workflow. So RGB is the layer of client-side validated state data, which is kept separately from the blockchain chain. But this state and data are linked to the blockchain through the mechanism of so-called single-use seals. And they work 2 ways. So one way, they assign state of RGB smart contract to certain existing Bitcoin transaction outputs. And on the other way around, the Bitcoin transactions commit to the actual content of to the hash of state transition, such that the history here is immutable and you can't do the double spending. That commitments are created with a thing we call tap-ret. So originally when RGB began, there was an idea of using sign-to-contract and later pay-to-contract variants of commitments. And also, of course, we all know about op-return commitments. And of course, RGB supports op-return commitments as a failback measure for something that is not compatible with the new standards, like maybe hardware signers and so on. But the first versions of RGB was a pay-to-contract versions, which was a very complex thing to manage from the wallet perspective, because you tweak the public keys and it's really hardly combinable with the descriptors and existing wallet libraries. So more than a year ago, we moved to the Taproot, which is Taproot-based commitments, when the actual commitment data are put inside Taproot script tree. And that allowed us to significantly simplify the infrastructure and do this thing in a much more efficient way. The contract state. RGB has, I already said several words about the state, and I would like to give more details on that. So the contract state can be of two different types. The first type of the state is the global state. And this is quite important type of state because this form allows what we call Bitcoin finance, DeFi smart contracts, where you can create something like automatic market making and other forms of advanced smart contracts. So this global state is known publicly. Everyone knows about that, and nobody owns this state. So it's not an ownership of somebody. For instance, a simple way to represent a global state is the name of the asset. So nobody owns the name of the asset. It's just information about the asset itself. And the owned state is the opposite of that. It is owned by somebody, and mostly nobody knows about this state. So it is only an owner who has the information about the state, and it will be up to the owner to make it public or non-public. Now, we have different forms of smart contracts. You can do NFTs, you can do digital identity, you can do assets. And the question is, you have a wallet and you download some smart contract, how you can get an idea how to interact with the smart contract, what to do with that. In the Ethereum world, you have things like ERC20 and other standards. Actually, you have a thing called API, application binary interface, which you download as a separate file. Here, we introduced a different form of the same idea, which we call interface. And it's a very important upgrade that happened this year. So we've been working for the last half of the year to bring it to RGB. And with this update, it was released just this month. And with this update, RGB is able to run any arbitrary business logic developed by independent developers without the need for the wallet to upgrade and to integrate some new libraries. So basically, interface is the binary description how the wallet interacts with a smart contract, and the wallet can download these interfaces. They're usually coming together with the consignment, so they're integrated automatically. And through the interfaces, the wallet creates invoices, and he can create the payments for the invoices, even if this is not just an asset, but some complex form of smart contract creating some non-standard operations. So that can be still represented in the user interface. The current set of interface developed by us and shipped with RGB is this one. It's not a restricted set, so anybody out there can create their own interface and distribute it. But we just like to have some starter kits such that people can simply start creating something with RGB. And this includes fungible assets. This includes digital collectibles, which in case of RGB doesn't imply that you store the data in the blockchain and you consume the blockchain space. You don't need to do that. Digital identity, you can create something like open timestamps, but organized in form of a log, such you just can prove the history of certain events and that there is no alternative history that exists for a set of events. And the global naming system like ENS, but much better because again, it's not on Ethereum, it doesn't require any token than Bitcoin, and it is much more scalable. Now, what is RGB operation? What means to create an operation with a smart contract? The operation is something that modifies contract state. And there are three main types of operation. The first one is genesis, which is just one per contract. It's how you create the contract. And genesis just doesn't have any input, creates the contract state out of nowhere. The state transitions, which modify the state of the contract. And the state extensions, which I wouldn't cover today in the talk, but the state extensions are important when you have, for instance, an asset that can have a decentralized issuance, such that you can think about state extension as a form of genesis, which can be created by not just by contract participants, but anybody out there. So state transition, it does have inputs and outputs as much as Bitcoin transaction. And an output of the state transition or output of the genesis is something that assigns an own state data to certain Bitcoin transaction UTXO. So you can have a Bitcoin transaction which already mined for 10 years ago, before RGB was even conceived. And then you create a genesis which assigns to this UTXO a state. And nobody except you knows about that, because there is nothing in blockchain that has changed. And that is called a single-use seal, and that's how actually RGB works with the state data. Now, if you would like to modify that state, like do a transfer of the asset from this UTXO, you create a state transition referencing the genesis output. You create a new assignment to another Bitcoin transaction, which now will be owning this state. For instance, I am transferring the assets to Giacomo, and he gave me his UTXO that exists there. And the very important thing that these two UTXO, the one that held my asset and the one that now holds the Giacomo assets, are anyhow unrelated. There is no transaction graph connection between these two transactions. And this transaction may have existed before even this transaction was created. And this is a very important property of RGB because it breaks the transaction history graph and it just devastates any form of chain analysis in this regard. And so this is the workflow, but you may say that, okay, I will do then another state transition, different one, double spending the same state to a different UTXO, so double spending is not solved. And that is how it's done with a single-use seals. You have this second part of the story that when I do the transfer, I also need to spend that output of my transaction. So this is UTXO not spent yet. I create a transaction spending this output, and this transaction called witness transaction. It has nothing to do with the SIGWIT. This term appeared from Peter Todd's work before the SIGWIT happened, but it's just a confusion that it's called the same. And this witness transaction can do anything. You can put whatever you like there. There are only two requirements about this witness transaction. First, it has to spend the output that you're using to do the RGB operation. And the second, its first output must commit to the state transition you just created. And this mechanism ensures that there could be only one state transition doing this transfer of the state, because you can spend the Bitcoin transaction output only once. And this transaction is fixed because you put the data of the hash of this transition into witness transaction. The mechanism of that called taproot commitment plus multi-protocol commitment. Why it's multi-protocol commitment? It's one of the complexities we had to face and solve was that this output may contain a lot of state assignments from different contracts. So it's not just a single contract. So you have to structure all this. You create, basically, when you spend output with the multiple contracts, you create a multiple state transitions for each of them. And because you would like not to expose the other contracts when you do a transfer to the beneficiary, you put them into a Merkle tree, you Merkleize, and then you commit to the root of that Merkle tree. Another thing that it gives taproot commitments interoperability with other protocols. Let's assume there would be another protocol like even Taro, which decide to use the taproot. They just use this structure and they commit to any data under any protocol inside this structure, and so RGB will be interlayable with any other client-side validation protocol. The actual structure is even more complex because there is a structure called anchor. It contains the proof how you put the commitment into the taproot tree, and this state transition actually is not a state transition but a bundle of state transitions which is required to do that for if you, for instance, create witness transaction, which is a part of CoinJoin, such there are multiple participants doing all their own state transition, and there is another merkleization happening here. So it's quite complex thing, and the reality is even more complex. That is the anatomy of the state transition of the anchored bundle of state transition in RGB, and it's much more complex than Bitcoin transaction itself because it can work with any form of the state. Not just like in Bitcoin, you have just one state amount of the Bitcoins. Here you can have any structured data, you can have Pedersen commitments to the amounts, and also you need to have single-use seals, and you can conceal all this data, make them private, wrap them, and so on and so forth. So the anatomy is really complex thing. In case of the Lightning channel, the same thing applies and works. It's just that you have now a multisig 2 of 2. So you create a funding transaction for the Lightning channel, and you create a funding state transition for adding the asset to that funding transaction. There is only one-way connection, so you can create a state channel. It can be operational. It may be created even before RGB was released. And now you can take an asset and start adding assets to the funding transaction. So you can use existing Lightning channel and add assets to existing Lightning channel without the need to reopen channel or create a new channel. And then what you need to do is just to create a state transition for the commitment transaction, which will redistribute this state or this asset across the outputs of the commitment transaction. And the commitment transaction will be also a witness transaction, so it would be two-way binding. And when you do an update of the channel state, you don't send the consignment over and over again through the Lightning Network, because you both have the state of this output. The only thing you do is that additionally to providing a signature to commitment transaction, you construct the commitment transaction in such a way that it contains a taproot commitment to the commitment transaction. Or in case that it would be demonstrated today, not a taproot, because we don't have taproot in Lightning yet. It would be for now an op-return commitment, because it's the only way you can add some data to the Lightning transaction today. So that's all about the technology itself. You can start learning more about it by looking into the resources which are still work in the progress, but we're gradually releasing them. This is a new RGB technology, RGB tech website, where we explain on the end user perspective how RGB can be used and what applications are there. There is a thing we call black paper, which is a white paper, but for the RGB as a privacy-based technology without a token in itself, so that's why it's something opposite to white paper, and it's like a satirical name, but it's a technical paper explaining all aspects of RGB technology. There is, of course, GitHub, and there is a number of organizations at GitHub. The main development is done by LNPPP Standards Association, which is non-profit, and it's actual association about everybody who would like to build on top of RGB, and it maintains the main standards and reference implementation of everything. GitHub also contains different forms of RGB libraries, so depending on what you're trying to develop, if you would like to build a server-side application or desktop wallet or mobile wallet or WAS and work wallet, you use different libraries, and this is the stack. And we have a clear layerization between the consensus level libraries, between the libraries that bring standard API and work with Bitcoin transaction, and then libraries that adds a file system and input-output on top of that, such that, for instance, you can use non-IO libraries from WASM or from hardware wallets, which doesn't have a C standard library. And end-user libraries that provide a high-level API to the wallets. Also, this RGB tools library is not a part of the standard stack, but it's a library developed by Bitfinex team. So it's an alternative API integrated with a BDK for those who are already using BDK. These are the repositories for this library. If you go to RGB/WG workgroup on GitHub, you will see these repositories, and that's actually exactly this library. So I will send the presentation so you can easily find where the things are. So the history is over RGB was quite long. It has started in 2016, and gradually RGB was developed through all these years, from the coins on Lightning into the smart contracts, which involved multiple things. I would like to emphasize that RGB was operational several years ago already on Lightning and as well main chain. It is that just through these years it continued to develop into adding virtual machine, adding special programming languages, adding more complex smart contracts. So today we are here, and with this version that was released this month, version 0.10, we call it, we actually reached all the targets that we had for the smart contracts and programmability. And after that, we are starting a certification process of the main protocol, such that no new features are coming, just the bug fixes. And today, Federico will be demonstrating another, and his team another milestone where they will do the Lightning channel routed payment. For the first time, it will be a routed payment using the toolkit that they independently have developed. So that's what RGB today. What will be happening tomorrow with RGB is that we will be adding now application layers, which will unlock these Bitcoin finance things on top of Bitcoin and Lightning, including all this cool stuff, which will leverage DLC, Oracle's Lightning Network, RGB all together to build the things which were unimaginable before. And it's not just RGB which is required for B5. B5 is actually a combination of three things: of RGB smart contracts, of Bifrost, which is an update to the Lightning Network, bringing Taproot support, and Storm, which is a data layer on top of Lightning Network, which we also have built last year. And there is a language for writing smart contracts. So if you do something trivial like issuing a token, you don't need to write anything, like it's a standard thing. But if you'd like to do something advanced, like here you have a decentralized ID bound to a certain token, and in that case, you write a contract, you do this implementation, and this language is a functional declarative style language, which is quite easy to learn. It's still work in progress, so you can't do this today. There is no finalized compiler, but that's what we will be working on after this release, is to bring this language and compiler to the market. This contracting language, it's placed in somewhere in the area where no other language existed. That was one of the reasons we had to do it. It's quite close to the bare metal, meaning that you have very clear representation of all data structures and you know the byte serialization inside the memory, but it's also functional, and that makes it different from other smart contract languages, which are shown in red, and from other programming languages that exist out there. You can read more about these resources of the language and virtual machine that is used by RGB. And now I just want to pass the word to Federico and his team to do their part. Thank you.
Okay, yeah, it's working. Okay, yeah, hello everyone. Yeah, thank you, Maxim, for part of the presentation. So yeah, now what we're going to talk about is specifically how RGB on Lightning is achieved, how it works, and then we will have a quick demo to showcase it's actually working. So first of all, a few words about our team. So yeah, we are a team in Bitfinex focused on RGB development. So Bitfinex is investing in making the RGB ecosystem grow and the technology around it be developed. We worked already last year. We released the Aris wallet, which is a RGB compatible wallet for Android. So now you can go on the Play Store, look for Aris wallet, and you can find it. It's currently on the testnet, but it's already fully working and you can play with it. We also developed multiple developers tools to help other people build on top of RGB. In particular, the main one is this RGB lib library that try to abstract some of the complexity of RGB and make people help develop a RGB wallet or other kind of application without having to understand all the internal details of RGB. And yeah, recently we released the RGB Lightning sample, which is the fully working Lightning node to add the RGB assets to a channel, move them between channel, and route them across channels. So very quick recap about a few concepts that we need to understand in order to understand how RGB works in Latin. So first of all, like RGB assets are assigned to Bitcoin UTXO. They can be new UTXO or UTXO already existing. And every time I do like a state transition, an ownership transfer, I move assets from one UTXO to another or a list of other UTXO. So in this example, some assets, some red token have been issued to the UTXO A. Then there has been an ownership transfer that moved them 20 of them to UTXO B and 80 to UTXO C. So probably it could be something like the payment was actually 20 tokens and 80 is the change that the sender is sending back to himself, but sends back to a new UTXO because the old one is no longer a new UTXO, is being spent. And in the Bitcoin transaction, this ownership transfer is committed inside the Bitcoin transaction that is spending the UTXO that was previously owning the token. So in this case, the first ownership transfer is committed inside the transaction spending UTXO A, and this one is committed inside the transaction spending UTXO B, and so on and so forth. And yeah, basically at the Bitcoin level, we just see a normal Bitcoin transaction, but in one of the output of the Bitcoin transaction, there will be a commitment to the RGB transfer that move assets from one UTXO to another. So yeah, this is the general super simplified idea of how RGB works, and it should be enough to understand how RGB is achieved on top of Lightning. So why? First, a question that many people could have is, why do we want to have assets on top of Lightning? Well, first of all, because Bitcoin greatly benefits from the existence of the Lightning Network, because you can move Bitcoin cheaply and with low latency around, and other digital assets may also benefit. So first of all, it's something that can be useful for digital assets, for the development of digital assets in general. In particular, I see like stablecoin as an evident use case of an asset that is already quite popular. They already used in payments, and in particular, USDT is a stablecoin that is being used widely for payments already since a few years. So it's something that could greatly benefit from something like Lightning Network that can offer cheap and low latency payments. And having stablecoin or other digital asset building on top of building infrastructure for the Lightning Network also benefits Bitcoin. Because, for example, let's imagine that a company develop a payment terminal to accept stablecoin on Lightning Network. With the same effort to develop that, they can also easily accept Bitcoin payments. That ultimately is something that can also help the adoption of Bitcoin itself, because there are a lot of people that are not ready to adopt Bitcoin yet because of the volatility or whatever reason. But if they start using a stable coin that uses the same technology of Bitcoin, then the difficulty to adopt Bitcoin at that point is much lower. So it can really help also the transition to a hyper Bitcoinized economy. And also, like for Lightning node, that today a lot of Lightning nodes they are running a not very profitable way, because to run a Lightning node you have some infrastructure cost. You need to have like a server that is always up, and you need to do some rebalancing operations. And what you get in exchange for that is like the fee of routing Lightning payments on top of the utility that you get from the Lightning node itself. But yeah, if with the same infrastructure you can also route other like stablecoin payments, or you can offer like an exchange service between stablecoin and Bitcoin on top of the Lightning network, then you have more revenue stream that can help you to pay for the infrastructure needed for so yeah, it's also something good for Lightning node operators in general. So let's see the general idea of how we achieve RGB assets on top of Lightning node. So basically, we say that the way RGB assets are moved around is by moving them, assigning them to one UTXO and make a non-machine transfer that move them to another UTXO. So when we want to create a lighting channel that is also hosting, so supporting RGB assets, what we need is that we can send these RGB assets, so stay a stablecoin, towards the UTXO of the multisig where you do the funding of the Lightning channel. So when you open a Lightning channel, you send the bitcoins to a multisig between you and the other participant in the channel, and together with the bitcoin, you can also send RGB assets to the same UTXO that has just been created. So basically, we just need a bitcoin UTXO that represents the funding of a Lightning channel to exist. We don't, for the scope of having RGB assets, we don't really care how many bitcoins are in this UTXO. We just care that it is basically sufficiently above the limit to make sure that it can be confirmed on chain correctly. Then how do we guarantee the security of the channel? In the very same way we do with normal Bitcoin Lightning channels. So we have this, for every channel update, we have this pair of Lightning commitment transactions. And what we do to secure the RGB asset with the same way we secure the Bitcoins is that we create a state transition, a transfer of RGB assets from the multisig of the funding transaction towards the outputs of the commitment transaction. Then we will see more into details with that diagram in the next slide. So we are just giving an introduction. Then when we close a channel, basically both parties move the asset from the output of the commitment transaction of the Lightning channel towards some UTXO that they control exclusively, and so they withdraw them to their own wallet in a way. So let's see more into details how all of this works. So first we have a funding transaction. So it can actually, a funding transaction can be a bit more complicated than this, like assuming that you want to get some change that your input was not exactly how much you wanted to send, but let's take a simple case. So we have a funding transaction where Alice is opening a channel with Bob, and so she's sending 10,000 Satoshi from her input to a multisig with Bob. So this is what you would normally do only with Bitcoin. So with RGB, what we do is that we create an RGB state transaction that moves asset from wherever like Alice was holding asset before, so from the UTXO of Alice, and we move them towards the new UTXO that is being created that is controlled by a multisig between Alice and Bob. So there is this first and only allocation of the state transaction is the output 0 of the transaction during the funding. And to guarantee the security of the RGB state transaction, the state transaction is committed inside, in this case, an operator output, but could be also like a tablet output using tablet. Yeah, is committed in a dedicated output to make sure that basically this is unique. There is it's unique that there cannot be an alternative state transaction that later can change. So okay, now we have asset inside the multisig of the Lightning channel. How do we guarantee that that both parties can take them out at any time with the correct balances between them? So same way as we do with normal Bitcoin Lightning commitment transaction. So this is a case of a Lightning commitment transaction that is prepared by Alice and signed by Alice and held by Bob. So in this case, the commitment transaction for the Bitcoin part, which is this part, is what you have if it was on Bitcoin only. You have 10,000 satoshis that are moving from the multisig towards the to output. So it will be with some different allocation of satoshis. So in this case, 9,000 to the first output and 1,000 to the second one. And some they go directly to Alice, and the other ones they either go to Alice if she knows the secret of Bob, or they go to Bob if a certain amount of time passed, and this is guaranteed by the time block. So the idea, if this is the last state of the channel, Bob will wait for the time block and they can take the satoshis. If this was an old state of the channel, Alice will know the secret of Bob and she can take all the satoshis assigned to this output. So what we do with RGB is basically we leverage this structure that already existed, and we just say, okay, those assets that were assigned to the multisig, so basically they were here, we move some of them to the first output that can be so that they can be directly moved away from by Alice at any moment, and another part of them to this output that is controlled by either Alice or Bob, depending on the situation. So basically what it means is that right now, of the 5,000 USDT that were in the channel, 430 are under Alice, and 70 have been sent to Bob. But yeah, only. But this will be valid only if this is the last state of the channel. After this, something has happened, and Bob tried to broadcast this, then Alice will be able to take also the 70 back, all of them 400. And all of this is committed inside a dedicated output, in this case an operator output, to guarantee that this cannot be changed. This is unique, and there is a strong link between the Lightning commitment transaction and the new RGB state transaction. This, for every channel update, this is done twice, because this is what Bob has as a guarantee to broadcast at any moment if he wants to run unilateral channel closure. While this is what Alice says, so which is the same thing but is specular. So in this case, 30 USDT are sent directly to Bob, they can take at any moment, and 470 are sent to this output with the two spending conditions. So either Bob with the secret of Alice in case it was an old state, or Alice by herself if she waited, if she managed to wait for the time block without Bob spending it first. And again, we have a dedicated output where we put the commitment of this transaction to guarantee that it is unique. But for now, we only saw like simple, like simplified version of payment channel where we just move money between Alice and Bob. But in reality, in the Lightning Network, we also want to do routing across channels. And so how to do this with RGB? Basically, the same way we do with Bitcoin. So with Bitcoin, so this is what we have in a Bitcoin only channel, which is what we saw in the previous slide, but by adding an extra output that is the one that is needed for routing. So in this case, like 1,000 Satoshi have been routed through this HTLC output, which has basically three spending conditions. Yeah, depending on if it was an old state and if a time lock is fired. No, I'm not going to go into details. I would assume that the general idea of how it works is already understood. But yeah, what is important is that on the RGB side, we just add an extra location. So in this case, 100 USDT are being routed across this channel, and we just allocate whatever is being routed in this output that is used in a normal Bitcoin Lightning channel to manage routing. So the thing is, if let's say there is a unilateral closure, and this is what the commitment transaction that Alice holds to do unilateral closure. If she broadcasts it, basically Bob will be immediately able to spend 70 USDT. Alice will be able to spend 330 USDT for the time lock, assuming this is the last state of the channel. And then in this case, knowing the secret of the payment bubble, we'll be able to take also the 100 USDT. But yeah, if the payment was going in the other direction, it would be X. So yeah, in this way, unilateral closure, everybody gets is the Satoshi that he should have, and everybody is able to, from these outputs, to spend the RGB asset and move them to ARM so that they control exclusively, and they can basically they can just sit on their wallet waiting for them to be used in the future. And again, we have the output to manage the RGB state transition. So this is yeah, how it works in theory. I hope it was clear enough. Now we will do a short demonstration of how it works with the Lightning node that we developed, and then we will have time for questions to address. Yeah, while everything is being set up, I will just share a few words about the Lightning node that has been developed. It's basically used Rust Lightning from the LDK team. We currently did just a very small fork of Rust Lightning to have some extra modularity needed to basically add the extra output in each Lightning commitment transaction. But it's a very small change, and we already had some initial talk with the LDK team, and it's an extra modularity that they are willing to add into LDK itself. So it means that all of this will leverage any future development of Rust Lightning without any extra maintenance on our side. So we just manage the RGB logic, and then whatever new feature will be added to the Lightning node by the Rust Lightning team, we will automatically get them. So which is also very good for long-term maintainability. So yeah, this is the demo. Maybe you can make the font a bit larger. Yeah. So yeah, this is the Lightning sample node, and we are in a reg test environment, so we will not have to wait for confirmations, otherwise it will be a bit annoying. And we will launch 2 nodes so that we can open a channel between the 2 of them and make a payment. So first of all, yeah, we get an address where we need to get some Bitcoin practice coins. Yeah, we need some balance to then be able to open the channel. Yeah, we're sending some Bitcoins to the address of the. Now we create some UTXO in the wallet so that we are able to allocate access to this UTXOs that we have. And yeah, here is the list of the UTXO that we created. And now we will issue a new asset, and we will allocate the issuance to one of the UTXO that we just created. So we just creating a new asset that we call USDT Tether, just to have an example. The asset and now we can verify that we have that has been issued correctly. So we have actually the asset balance in the wallet. say now we have a wallet with some balancing and RGB asset. So the next thing we will do is to open a channel with the counterparty with some asset. So this is open channel with yeah, local. So basically, we're opening a channel with this node in this location for this amount of Satoshi and this amount of assets. And yeah, we define which asset we are adding to the channel. Okay.
Is it on local host? Yeah, so you need to connect. Connect here, and then I think the local channel is mostly
well, yeah, when you do demos, it's never easy, but it's worth it.
you need to connect to the field first.
Okay, so it's starting to open the channel, and you know, the communication between the two parties is been open, and yeah, they need to. Yeah, you can see on the other. This is on the other side of the channel, the other party. So we can see that they started on one side, and so yeah, now they need to do a bunch of stuff like yeah, coordinate for the funding, the commitment transaction, and the RGB state transition. So yeah, let them do the work. Okay, channel has been opened. Now we need to mine 6 blocks to confirm them usable. And now should be ready to be used. So yeah, channel ready through. And now we can do the payment between the two parties. We will just use a key send. We get the ID of the node towards where we need to send the payment. We define an amount sent. First the amount of Satoshi, then the RGB ID, and then the amount of the RGB assets. So we're sending 50 USDT. Fail to find the path to destination. Maybe you need to put the node ID with also the IP address.
You need to send to a channel. You need to switch to the channel.
Maybe the amount of millisatoshi was too high. Yeah, I think you try to send too much. There is an extra zero. Oh yeah, it's and the link, yeah, it's updating the channel. So looks like the payment is went through. So yeah, probably the other node now is also validating the RGB transition. Okay, now it's been RGB transition should be okay, so yeah, we can see that the amounts are changed. Instead of being 200 local amount, now it's 150. So we successfully sent it 50 tokens to the counterparty with that Lightning payment. And now, yeah, we can try to close the channel. And now, yeah, they are doing the cooperative closing of the channel.
The funny part is the group has started. It was a test.
Okay, yeah, the channel has been closed. So yeah, we opened the channel, we made a payment, we closed the channel. And yeah, now we will mine to confirm the close. Okay. So now if we look at the asset balance after the closure, it should reflect what was the state of the channel when we closed it. Yeah, so initially we had the issue 1,000, then we put 200 in a channel, we sent 50 to the counterparty, we closed the channel, and now yeah, we have only 950. So yeah, thank you very much.
So we have around 5 minutes for Q&A, and then we can keep talking like we did last time. So yeah, if you have any question.
When Tether or Lightning?
Well, I mean, it's not up to us. I mean, Tether will not move quickly with the experimental technology, which is still the state that we are in now. So yeah, eventually it will happen, but there is not defined roadmap yet. So yeah, we just whenever there will be confidence that all of this is very safe, very secure.
2 weeks.
Maybe.
Before the dollar collapse.
Someone else? Okay.